This slide gives you a few options that you might find useful. So you generally stick options after the proc SQL and before the semicolon. So for example, if you add the feedback option, this just tells SAS that you want more detail, give me more detail in the log. If you want to restrict the number of cases that get printed, out obs does it. So this is analogous to the obs equals statement that you've been using with procs in the data step. In SAS SQL, you could also attach in parenthesis obs equals 100 after naming any data set. So in a from statement, if you said, select star from sscc.employee, then you say parenthesis obs equals 10, that would just pull the first 10 observations. Sometimes you only care about checking the syntax of your code when you're developing a program. You don't, if you're working with very big data sets, running it could be very time consuming and demanding of computer resources. So while you're developing it, you might want to just be checking your syntax. So if you add a no exec option after SQL, that tells SAS just check the syntax, print out any errors in the log, tell me if you're happy in the log, if you like my syntax. You can reset any of these options with the reset and the option command anywhere in your after proc SQL. A few other related commands, these are a little bit different than select statements. You can stick a validate in front of any select statement, and that just validates one select statement for you. So it doesn't execute it, but it will check the code out and show you in the log whether or not it likes it. Another command that's kind of in this same theme of options is describe table. So if you say describe table and table, it prints to the log something like proc contents. Not as detailed, but it's useful nevertheless. So I put together a little example just to show us what these things do. So I'll first assign the lib name. Let's invoke proc SQL. And if I say describe table sscc.employee, this is what shows up in your log then over here. And so what you'll see is it lists all the variables. It tells us that in this data set they're all numeric. It tells us what the label is, and then if there are any formats associated with that variable, for example, I guess I associated the $8 format with annual salary, it also shows that here. Now, let's say I stick a validate statement in front of something. So let's validate select star from employee dot whatever. Now, if you go over to the log, you'll see it shows you exactly what I typed, but then it also says note, SQL statement has valid syntax, so SQL is very happy with that. So again, when you're debugging, that's very useful. Now at this point, I'm going to turn on feedback. So if I say reset feedback, remember what feedback does up here, it produces detailed log messages. Let's run that same statement again, but this time I'm really going to run it without the validate option. So select star from employee. If you look over in your log, now SQL expands, or SAS SQL expands what that star means as an example of what feedback means. So it says, note this statement is transformed into select employee.employee num, salary, and lists all 6 variables. So it's just telling you, what does star mean? Well, what star means is all of these variables. So those are a few of the options that you may want to use. Let's go on to another useful keyword. So distinct just says give me all unique combinations of whatever variables I list in my select statement. So let's go through a tiny example. Let's say I have this transaction file from a retailer, and in this transaction file I know the customer ID as well as an order number and then the amount of the order. Now in real life we'd probably have a date with this and what SKU was purchased and the quantity and the price, but we'll keep our example simple. Alright, so notice what I have. Customer 1 really only has one order. So the customer 1 has order 10. 2 items were purchased. One was $100, another one was $120. Let's go on to customer 2. It looks like customer 2 has 2 orders. So the first order was order number 11, had 2 items in it. Then he came back the next day, I guess, with order 12 and purchased something for $150. Customer 3, on the other hand, only has 1 order, order number 13, which cost $160. So if I print everything from this, here's what you get. It looks like it read it incorrectly. Now let's get some practice with this distinct command. So if I said select distinct ID from trans, what it returns is just 1, 2, and 3. So those are the distinct customer IDs. Alternatively, if I said select distinct ID, ordnum, what that says is give me all the unique combinations of ID and ordnum. So what it's going to return is 1 record for customer 1, 2 records for customer 2, and 1 record for customer 3. Another thing that you can do is stick this within a count statement. So if I said select count distinct ID, what this is first going to find out what are the distinct IDs, then it's going to count them, and so what's returned is a variable ncust, because I said as ncust, which takes the value 3, indicating that there are 3 distinct customers in this data set. To do this with a data step, the data would have to be sorted first, and I'd have to use first dot and last dot processing. So I would have to set my data set by customer ID and only keep, say, the first record for each customer. Then I'd go look in the log and find out how many records were kept by that. The other way that you could do this is with a proc sort. You may remember there's an option for proc sort called no dupe key, NODUPKEY. That would also accomplish this. So regardless of how you do this, whether you do it with proc sort or whether you do it with a distinct statement in SQL, it's going to require sorting. Sorts are pretty expensive, so you want to use this sparingly. And that's about it. So here are some exercises for you to try on your